You came back to learn more, and that's great. Binary arithmetic and overflow, that is just what we are going to discuss about in this video, okay? So we discussed about how to change signed and unsigned values or integers to binary. In this video, we will be just discussing about performing some arithmetic operations on them. So it is just not very different from what we have been doing with Denary till now, okay? Only you have to just know that, yeah, in Denary, base is 10 and largest digit that we have is just 9. And when we just get to 9, then we just simply roll over, okay? So after 9, it will be just 10, 0 will be here, and 1 we will have just there, okay? And in binary, we have just gotten base 2 and our largest digit is 1. So we cannot have 2. So after just we crossed 1 for the next one, we will just have to write 0 here, and we will just have to just carry 1 to the next bit, okay? So 1 plus 1 will be 2, and 2 in binary, that is 1, 0, okay? So 0 written here, 1 there, and just after that, yeah, if we had just anything, we would be just counting that, okay? Right now, we will just simply have it here. So both systems calculate strictly from right to left. It is not very different from the same Denary addition, okay? It is the same, simple. The only difference here is that we have gotten only 2 digits, okay? 0 and 1, and our largest integer or our largest digit here is 1. So we have gotten 5 golden rules for binary, okay? The first one, 0 plus 0, that is 0. We just know that, okay? And 0 plus 1 is 1. Good. 1 plus 0 is 1. That is just also nice, okay? But here, 1 plus 1 becomes 2. And 2 in binary, that is 1, 0. So 0 is just written as a result, and 1 is just carried, okay? 1 is just used as a carry. And after that, 1 plus 1 plus 1 becomes 3. And 3 in binary is 1, 1. So 1 is just written as a result here, and just the other one goes to the carry, okay? See, here we have just gotten the same thing. 1 plus 1 will be 2, so 0 will be here, and 1 will be carried, okay? And just that will be written here again. Or just here, 1 plus 1 plus 1 will be, so yeah, 1 is written here, 1 will be just go to carry, and we will just simply have that back here. And next, yeah, we are just going to perform some additions in binary. How does just computer work, okay? So see here, we have gotten 43 plus 25. We want to just perform this in computer. We just want to see how just computer does this, okay? So first of all, computer stores them as binary. In exam, if they just simply tell you to perform that in binary, the first thing that you'll have to do is to convert them to binary, okay? So converting them to binary, both of them are just positive numbers. So let's just do that, okay? So 43, we cannot have a 128. We cannot have 60 from this. But yeah, 32 we can have, okay? So if I just cut 32 from that, we will just have 11. So 16 we cannot have. 8 we can have, okay? 11 minus 8, again, just simply we'll have 3 there. 4. So we cannot have. 2 we can have. So that will be 1, and yeah, 1 we can have. So that is 43, okay, as binary. And 25. So from 25, we cannot just make a set of 128. So 0. We cannot make 64, 0. 32, we cannot make 0, okay? We can just make 16, so that makes it 25 minus 16 will be 9. 9 will just remain. So out of 9, we can just make a set of 8. So that will be 1. 1 will remain. So we cannot make a set of 4. We cannot make a set of 2. And we can just make a set of 1. So that is our binary numbers, okay? Now, computer just does the addition on this. And after that, the result will be changed back to Denary. So now, let's just add them. Okay, in addition, so we have just gotten these 5 rules that we told you. Let's just do them. Okay, 1 plus 1 will be 2, and that 1 plus 1 is 2, so 1 is written here. 1 will just go to the carry. Again, just 1, 1, again it will be just 2, okay? So 0 here, 1 here. 1 plus 0 plus 0. Okay, so 1 plus 0 is just 1, so simply we'll write here 1, no carry there. Okay, so 1 plus 1 will be 2, again 0 here, and 1 will just kind of be carried. Okay, so again 1 plus 1, again 2, so 0 will be written here, and 1 will just go to carry. Then 1 plus 1, again it will be 2, so 0 here, and 1 will just go to carry. And 1 plus 0 plus 0 will be 1, that is 1 plus 0. Okay, so that will be 1, and no carry there, so 0 plus 0 will be 0. Got it? So that is just the arithmetic or addition done. It is kind of the same like Denary, only here the largest digit that we have is just 1, and after that, yes, simply it will have to just roll back to 0, and we'll have to just have carry. Okay, now converting this to Denary again. So yeah, we have gotten one set of 4 and one set of 64, so that will be 68. Okay, so this is changed to 68. So our final answer is 68. So as you can see, we can just simply perform the addition the same way we just do on denaries. So adding signed integers, the subtraction hack. Okay, processors cannot subtract in computer. Instead, they calculate a minus b by adding a negative number. So see, using one of the benefits of using 2's complement was this, that yeah, we would not need separate hardware to just perform a subtraction. You would just simply change one of these numbers to negative, and after that we would just perform the addition. Okay, so positive integers, example 5. So then after the 2's complement conversion, flip step 1, flip all bits. Okay, write the positive one, then flip it, then add 1 to just get the result. Okay, so you will just simply have the negative integer of that. Then now for doing this subtraction as well, we are just ready. Okay, so ready for standard binary addition after that. So again, we'll just be working on examples on this. You can just understand them better and better. See, addition, signed addition, 10 plus negative 5, or we could just simply have 10 minus 5. So 10 minus 5, computer would just perform that as well like this. Okay, it would just change 5 to negative, then it would perform addition there. So we have gotten 10, 2 plus 8, that is 10, and 2's complement. Okay, that is negative 5 in 2's complement. You can just do the steps again. So what were the steps? Write the positive 5, then flip it, then add 1 to that. Okay, so simply you will get this. So this is negative 5. Now see, if I just do the addition here, 0 plus 1, so 1. 1 plus 1 will be just 2. 1 will just go to carry. Okay, so 1 plus 0 will be 1. So nothing to carry. 1 plus 1 will be 2, so 0, 1. 0 will be here and 1 there. Okay, 1 plus 1 will be just again 2, 1 there. Okay, I've just not written the carry here. So 1 plus 1 again will be 0, and just 1 carry here. Okay, 1 plus 1 will be 0, and 1 carry here, and 1 plus 1 will be 2. So we will have just 0 here, 1 will go to carry, and we will just have it here. And because this is now outside the 8 bits, it will be deleted. Okay, it will be ignored. So that's it. Okay, try to just do these questions on a paper for yourself to understand them better and better. See, the overflow error defined. Okay, a condition where an operation produces a result that requires more bits to store than are available in the computer's fixed length registers. So for example, you are working in 8-bit registers, you are working with 16-bit registers. If just computer produces a result that requires more bits, then what? Those bits will be just deleted. Okay, so it's in the same example that we just worked on, this one will be just simply deleted. Okay, and causes and consequences, what are just kind of the, what is the result of that, what is the reason and result of that. Okay, the cause, that is hardware limit. Registers are fixed widths. there is literally no extra physical space to store the overflow bit. So if you have just gotten 7 bits or 8 bits, if you have gotten 8 bits, so you do not have the ninth bit to store that. So that will be just deleted. Okay, there is just no way to store the ninth bit. If you're just using 16-bit, for example, yeah, there is no way to store the 17-bit. Okay, and the sequence and the consequence, okay, that will be just a system failure. So first of all, mathematical inaccuracy. For example, if you just add 130 plus 130, that will be just 160, and 160 is higher than 127, which was just kind of our upper bound. Okay, so computer will just show that as 4, 127 and 160. So again, it will just kind of round and it will just show you 4. Corrupted data output and catastrophic program crashes. Okay, many times if just this overflow is not handled with by the high level language, then simply our program will crash. Okay, so these are just the consequences. Okay, and while writing programs, we have to be very careful about this. Okay, because not paying attention to this can result in big failures. Okay, there are just many failures only because of this, but a very big example of this is the real world impact Ariane 5. Okay? So date in 1996, 40 seconds. Okay, now that is time of failure. Root cause, okay, unhandled overflow error. What was the reason of a very big rocket to fail? Okay, so the rocket software attempted to cram a 64-bit floating point number into a 16-bit hardware space. So it was coded to just generate a 64-bit floating point, and the space that was just considered for that was 16-bit. So this triggered a cascade of system overflow crashes, resulting in the total destruction of multi-million-dollar payload. Okay, so you have to be very careful about this thing. Exam style practice, task 1, calculations. Okay, calculate the result of adding the two 8-bit binary numbers, this one and the other one. Okay, so let's just do that. So this is for your practice. Okay, do this addition and write your answers in the comment section. Okay, so we can see how many people have just tried that and how many people have just solved it correctly. Task 2, theory. Explain one reason why the result of adding two 16-bit binary patterns together must be 16 bits in length. For that one reason, yeah, you have to just give 2 parts because it has 2 marks, and we just discussed about that. Okay, and master exam tips. First of all, again, calculators are not allowed on your exam, so you have to just be very careful about that. Okay, learn to do all your calculations on paper. Always show or write your carry row. Okay, the carries, just write them. Why? Because in IGCSE exams, the method will also be marked. Okay, so you will have just some scores only because of the method. If just that is wrong, if you do not write that, you may lose the method mark. And if assigned addition generates a 9th bit, write it in the brackets to show you know it exists, but it is discarded by the register. Okay, so you have to just even show that. That's it. Wish you all the best. Come back to learn more, and do not forget to like and subscribe our channel. Okay, introduce us with your friends. Good luck and goodbye.